So let's go for the introduction of RFID. So what is RFID? RFID stands for Radio Frequency Identification. It's a technology that employs electromagnetic fields to automatically recognize and track tags attached to objects. These tags hold electronic data that can be read remotely by an RFID reader. RFID is extensively utilized across multiple industries because it enhances efficiency, accuracy, and data management in tracking and identification operations. So, next, the obvious benefit is that we can scan an RFID tag from up to 30 feet away without needing to have direct line of sight. Furthermore, compared to standard barcode, RFID can hold a lot more information, ranging from 96 bits to over a megabit or 125 kilobytes, and a common barcode has a maximum of 30 bytes or between 12 and 30 alphanumeric characters. So there are various types of RFID product. Basic system may store up to 12 bytes of product data, while more advanced system store significantly higher quantities of data and permit read or write access to RFID tag. A certain RFID tag is employed as a security measure in retail establishments. The reader scans that exit with its antenna to determine whether the bit is there. Let's move on to the key components of RFID. So here we have three main key components of RFID. So the first one is tags, which is a transponder. So we have passive tags, which is do not have internal power source. So they rely on the electromagnetic energy transmitted by the RFID reader to power the tag and send back information. For the active tags, so they have their own power source, which is battery, and can transmit signal autonomously. So for the semi-passive tags, they have a battery to power the microchip but communicate using the reader signal. So for the second one is readers, which is interrogators, devices that emit radio waves to query the RFID text. So readers can be stationary or mobile and are equipped with antennas to transmit or receive signals. So for the third one is antenna. Both text and readers use antenna to communicate. So the antenna in the tag capture energy from reader signal, and the reader's antenna receives the data transmitted by the tag.
Farhuda Binti Mansur going to explain about the principles of radio frequency identifications. As my teammate mentioned before, RFID systems works by sending radio waves to each other to identify objects and mapping of the data. Before we jump to the working principle, let me introduce you to the types of RFID tags. These are types of RFID tags which are active, passive, and semi-passive. For active RFID, it has their own power supply embedded to it to transmit feedback to the RFID readers. It is also provided a larger range of reading. Next, we have the passive readers that have no internal power supplies, which make it relies on the signals sent from the reader to transmit its feedback. Reading range is limited compared to the active RFID tags, while in case of the semi-passive tag, it is better powered but transmit its signal to reader. It requires energy from the electromagnetic wave from reader. The RFID systems consist of RFID readers and RFID tags. For RFID readers, it consists of three components. The first component of the RFID is radio frequency signal generator. It is for generates radio wave to transmit through antenna for RFID tags. Receiver or signal detector is detect signal of feedback which is coming from the tag. Microcontroller is the components that process the data after receiving feedback signals from the tag. As the passive RFID tags is widely used nowadays, so I'm going to explain about the passive RFID tags, which consists of transponder, rectifier circuits, and controller. Transponder is used to receive radio wave from reader and also send the feedback signal to the reader to process informations. As the passive tags have no self-power supply, it relies on the energy that is coming from the reader's electromagnetic wave. Rectifier circuit is where the energy is stored that can be used for controller that as the memory element. The working principles of passive tags depends upon the frequency of operations. For high and low frequencies working principle, it is based on inductive coupling that is also known as a near-field coupling. As the reading range is short, so the reader and text are placed close to each other, so the radio wave from reader can be detected by antenna of the tag. The frequencies transmitted from the reader will be the same as the signal of the feedback from tag. Signal of the tag can be sent to the reader by switching off the circuit that is known as load modulations. From this process, our RFID readers can read data that is stored in the tags in the form of voltage. For the far-field coupling or electromagnetic coupling is the base of working principle for ultra-high frequency. The process of sending back signal to RFID readers using backscatter signal is known as backscatter modulations. The tag is sending a weak signal to the reader that is called as backscatter signal. This signal sent from the reader must be strong so that the signal from the tag can be received by RFID reader. If the load is matched exactly, the intensity of the backscatter signal will be more.
For the next slide, I will discuss about application of RFID technology in tracking. Let's discuss about this slide. First, asset tracking is used to efficiently track valuable assets documents. For your knowledge, RFID make it easier to track expensive documents and assets. For example, RFID tags are used by the construction, transportation, and laboratory sector to track and manage valuable assets, to ensure they are where they need to be when required. Second, access control is used to access control restrict areas. For more information, access control systems based on RFID technology are widely used in workplace, buildings, and sensitive areas. For example, RFID access cards or badges provide only the authorized personnel to ensure safety by allowing for easy access. Lastly, inventory management is a tool for tracking and managing inventory items using RFID tags and reader. For example, RFID is used by shop to track inventory level automatically. Items that with tags help keep accurate inventory count and decrease the number of out-of-stock products.
Next is identifying objects, inventory management, access control, and electronic toll collection. First thing first, for the objects, RFID tracking works by putting data, ID, conditions, amount, position, etc. to an RFID tags, active, passive, or semi-passive, and physically attaching it to the appropriate asset, which then can be read and captured in asset tracking system. Moving to the next point, which is inventory management. RFID inventory management need a use of a scanner that communicates with RFID tag via radio waves. So what are the pros and cons of using RFID in inventory management? Pros is improved visibility and faster scanning. This is because it can be read from a certain distance, unlike QR, which can be scanned line in line. Next, it lessens the labor cost and use minimal to no employee. Whereas for the cons, the phone is unable to use RFID. The next cons is security concerns. Remote devices as mobile phones can be used to scan and copy tag data from close range. This is why it makes it prone to hacking. Right? Access control. The RFID do all the hard work by handling access approval. Each RFID reader sends signal, allowing readers to grant or refuse access to specified facilities depending on access level or permission. So what are the benefits of using RFID on access control? And also, what are the drawbacks of using RFID? The benefits are RFID chips are very durable products, which mean less time and money spent. It also can be used in almost any kind of weather. The drawback is the same as inventory management, which it can be hacked easily and making it less secure. Last but not least, which is electronic toll collection. Toll plaza readers read RFID tags attached to vehicles. The technology instantly deducts the toll amount from the car owner's account, allowing for quick and effective toll collecting.